So hello friends, welcome to e-mobility system lab. Today let's understand the architecture of a battery management system, commonly known as a BMS, which is one of the most critical subsystem in any electrical vehicle and energy storage subsystem. So the battery management system is responsible for monitoring, protecting, optimizing the performance of the battery. Starting from the left, so let's start from the left. Basically, this is a battery pack and it consists of a number of cells in the series, and all the cells basically are connected to the cell monitoring units. So the purpose of cell monitoring unit is to monitor the voltage of the cells or voltage of the battery pack, temperature of the battery pack, cells. It is also responsible for cell balancing and current monitoring. So basically all the parameters like voltage, current, temperatures are first monitored, then sent to the battery management systems. Okay, and we are having one current sensor which is responsible for measuring the current of the battery pack. Okay, so this cell monitoring unit is responsible for monitoring the whole battery pack voltage or individual cells voltage, and here we are monitoring the individual cells current, but here we are monitoring the complete pack current. So the whole battery pack data we are sending to the BMS unit. So basically, BMS unit is nothing. It is basically a microcontroller which is responsible for estimation of SOC, SOH, SOP, and it is also responsible for cell balancing and fault protection, diagnostic, data logging, storage, thermal management control, protection and safety controls. So basically these are the core functions of the BMS, and here we are able to understand this microcontroller, this BMS unit consists of memory unit. So memory is basically flash, double EEPROM and RAM, and some kind of communication interfaces it has. Okay, so basically, let's talk about the how BMS monitor the voltage and current. So it monitors the voltage and current through the ADCs. So there are multiple channels of ADCs through which cells voltage and current are measured. And here, basically, the first what BMS is doing, BMS is communicating with battery pack, taking the pack data, voltage, current, temperature, and it is sending the battery pack data to the external systems basically. So what are the external systems? External systems like electrical vehicle controller, EV charging system, electrical vehicle HMI, and sometime it also send data to the cloud, and it also send data to the diagnostic tools. So with the help of diagnostic tools we can understand any kind of fault in the BMS, or the battery pack is correctly working or not working. So such kind of diagnostic we can do. So basically how the BMS communicate with external systems through the communication interfaces. So here we have CAN FT. Generally in automotive we use CAN-FT. RS485 we use UART, Ethernet and Bluetooth. Okay. So these are the communication interfaces which are used to send data from the BMS to the electrical vehicle parts or electrical vehicle ECUs basically. Okay. So suppose you want to send data on the cloud, so we will use Bluetooth or Ethernet we can use. Okay. So in the downside you are able to see the balancing drivers basically. So balancing drivers are responsible for activating, deactivating the balancing of the circuit. As we understood, there are two kind of balancing, active and passive balancing, and generally companies provide the passive balancing because it is cost effective. And the balancing of here the working of both is different. Passive balancing works in a different way, active balancing works in a different way. So let's understand the complexity of the implementation. So passive balancing you can implement easily, like it is not too much complex in terms of active balancing. So passive balancing is based on the resistor, and active balancing is based on inductor and capacitors. So there is a one drawback of passive balancing, or which we need to take care that when we implement the passive balancing, or balancing is done through the passive balancing circuit, then it generates some heat when it transfer the charge from one cell to another. It generates the heat. Okay. So the purpose of balancing is to make sure that all the cells of the battery pack are at equal voltage. Okay. So if any of the cells are not equal voltage, then it means the balancing is not working. Okay. So until or unless the balancing will work, we cannot charge the electrical. We cannot charge the battery pack. Okay. For charging the battery pack, we need to activate the balancing. Okay. So here are some protection and power control units. So basically, as we are able to see the balancing drivers, protection and control units, these are the part of the BMS. But here the representation is slightly out of the BMS just to make you understand the things. Protection and power control. The purpose of protection and power control circuit is to control the contactor and relay. Okay. And it is also able to control the pre-charge circuit. So in the upcoming videos, we will understand what is the pre-charge circuit, how it works actually. And a protection circuit helps us from the various protections, basically various faults. So let's understand what are the key protection features of the BMS. Over voltage protection, under voltage protection, over current protection, over temperature protection, short circuit protections. So these are the main important protections which should be available in the BMS. Okay, we have to protect the battery pack from over voltage, under voltage, over current, under current, over temperature, under temperature, and short circuit. So there should be no short circuit, otherwise your battery pack will blast. Without a robust BMS system, lithium ion batteries cannot operate as safely or efficiently. If you want to operate your battery pack in a safe state, you need BMS. Without BMS, you cannot charge or discharge your battery pack, or you cannot monitor any fault in the battery pack. So basically, we understood the architecture overview of the BMS. If you have any doubt, then you can write down in the comment section. Okay. At e-mobility system lab, we provide hands-on training on BMS architecture, battery algorithm, embedded firmware development, CAN communication, and many more. So guys, if you have any doubt, then you can ask me. You can write it down in the comment box. I will give you the answers basically. So if you like the video, then subscribe the channel for more videos.